So this is breakout session number 1. Let me get to my title slide here. Okay, just so we know where we are. So the topic of this breakout, like Kelsey introduced before we left the plenary, is on the infrastructure needed to do real-time support of Artemis science. Kelsey is running the one on architecture, and there's some overlap between where these questions will take us, and that should be okay. We just want to make sure that we get as much input from you, the community, as possible. So just some ground rules. Again, community participation is really vital here, so don't be shy to make a comment either verbally, so raise your hand, and I can't see the hands this time, I couldn't yesterday, or in the chat window. So either way, and me and Marie, and I'm not sure if Ferris is with us, Marie, but between the two of us at least, we will keep track of questions, okay?
Hello, I am here.
All right, excellent. So the team is back together. All right, so we will facilitate sort of questions and documenting all the comments. All right, so just to get into this, so I had this up on the screen while we were waiting for the meeting to start. These are the driving questions that I think NASA is the most interested in. So let me just go really quickly through this. And I thought we'd structure this so we'd spend like a third of the time on sort of 3 different groupings of this. So the first set of questions has to do with physical space. So for the science support team, where should they be located? What kind of physical rooms? How should they be laid out? How should the science team be physically sort of in relationship to other components of mission support? What about distributed science support, not having everybody in the same place? So all those questions. The second chunk of questions has to do with tools and instrumentation. So what science team tools and capabilities will enable the crew to accomplish their science tasks on the moon? What technologies can enhance situational awareness on the part of the science team? And what tools, capabilities on the lunar surface can enable the science team to do their work? So what data streams, okay, imagery, voice, what have you, are going to be required to enable real-time science? What's the relative priority? So hopefully we can maybe even come up with a prioritized list of these things. And then for each category, what are the requirements? And the last category we'll talk about is sort of lumped computing and communication together. Sort of what are sort of the hardware, software capabilities that are needed to process, store, disseminate, transmit all that data. All right, I already see a hand up. Let's see whose hand is that. Pamela Clark, welcome.
I'm trying to unmute myself. Can you hear me?
I can hear you just fine.
Great. Okay. So I want to say something about the physical space, and I will say my comments early because I do have to leave before we finish. I have a quadruply packed schedule today. So
absolutely.
In terms of the physical space, the beauty of this concept of the extent of the back room is that it doesn't have to really be in a physical space anymore. We can have a global network essentially of folks that can be available 24/7. They don't have to be physically connected with each other, though I have to admit I personally like face-to-face interactions with people, and it is more efficient in getting the point across sometimes. But the availability of the tools I think should be to everybody. I think that they can be largely distributed. There are 2 recommendations I would make in regard to the use of the space. One is that it would be a great idea to familiarize the folks that could be in this extended back room with the kind of training that the astronauts receive in terms of the field training they get, which is, I think, kind of special for the kind of environment we're putting them in, as I said in my talk. And the other piece of this is that we still have, one of the things we do have to figure out is, because we can have a lot more participants, we can't just have an open fire hose to the astronauts. So how exactly are we going to manage the inputs to the astronauts? During Apollo, it was done with the Capcom. And sometimes the science backroom folks expressed frustration at having to deal with they thought that it was a limited channel and there's going to be a lot more kind of information. So perhaps the idea of having a person who kind of coordinates the backroom achieves kind of consensus. Harder to do online than in person, it's true. But this would be solving those 2 issues about how we're going to expose people and make them familiar with the things the astronauts are doing, the kind of approaches they're using, and how we're going to deal with the communication when we have a lot more people, as we want, of course, participating.
Yeah, that's great feedback. Thank you very much. So yeah, since we started on the physical space conversation, who else? I think Ben, you have a comment.
Yeah, I just wanted to say on that, to extend that, you could think of it as what is the information that needs to be given to a broader scientific community that's going to allow for, say, overnight replanning. Like there's different levels of triage that are required for what we're all referring to as real-time ops. So if you think, yes, there's somebody that needs to make trade-offs on the current EVA because they're running late on something. That's a very small core team of people that are, trained to do that, and they've gone through all the training. But then there might be there's a broader set of discoveries that hundreds of scientists are potentially getting access to near real-time or real-time information. They're not in the back room, giving real-time feedback, but there might be some kind of way to give a voice to those expertise to say, hey, you found more of one material than another than we expected. What could that mean? And does that potentially change what we should do tomorrow? And that's a different, longer term kind of considered type of approach. It's probably similar to MSL and Perseverance. It's like a little bit more of a discussion than $1 million every person second on the surface, triage that we're used to from the Apollo. So I just wanted to bring that up.
Yeah, that's a great point. How do you think that would map to some of these specific questions about physical space or prioritization of data streams?
Yeah, well, I think it could be, so for physical space, you'd want that core team physically together. I would just, throw that in there as feedback from me. But then you're not saying that's so therefore we don't need all the systems that would get information to other people, because we want that, you could almost draw it like concentric circles, information being exposed to a broader and broader group of people. I'm biased because the information systems that I'm literally making all day, every day right now are literally designed to do that for ISS right now and for other systems. But that's what we're seeing. We're seeing that as you make a system like this, it just winds up people find uses for it and want it in ways that you didn't anticipate, because you're making it for a core audience, and then it becomes useful for lots of other people. So that these systems actually reduce that physical space requirement. That you're using the power of the internet, as it were. Then you can just say, well, we can hear from many more people. We're using the power of information systems for that. But then you're still getting that physical face-to-face interaction from the core team.
Yeah, that's great. And that's a really interesting point, that it seems like the physical space requirements can be offset to a large degree by how we prioritize things like data streams and how we sort of deal with that in an information systems way. That's great. Thanks. Marie, you had your hand up.
Yeah, I was just thinking about how with MSL, it was actually really nice when we first landed, we were all in the same location. And then as the mission continued on, that's when we actually went to those separate locations. So I think the length of the mission and how long that experience is going to be really changes the amount of physical space you're required and that face-to-face interaction. I could see if we ended up doing like month-long missions or something like that, maybe that physical space isn't as important, but at shorter lengths, then it could be a much larger factor.
Yeah, absolutely. So yeah, this goes back to a comment I think Pascal made yesterday, that as emissions go on and become longer length, that we should be flexible in how those missions are run, and that I think will affect directly the physical space and the technology needs.
Just sorry to add quickly to that. I did hear at another presentation, this was some time ago, that there's a huge cost difference too in deciding to have your personnel all together and they need to be in this mission control room versus maybe you stay at your university and you're using these information systems. So if we're planning for long-term Artemis human presence over months, years after these early missions, that's going to maybe be something we want to take as a takeaway, that we could move into that, and it just becomes more efficient.
This is Pamela Clark again. A hybrid where you can take the best of both worlds in a sense is to have one centralized center, but have clusters basically where you might have several centers where you can have some face-to-face time, which is good for the groups, and it can be easier to achieve consensus about things that you'd like to contribute or things that need to be done or recommendations you'd like to make. And you can still have it can still be extended, so you don't have to all be in one physical space to have efficient communication going on.
And maybe I'm incorrect in this, but I think that's largely how the Mars rover operations work, right? There's sort of centralized hubs in various parts of the country or the world where sort of instrument teams sort of work and they're distributed. Is that right, Marie?
Yeah. Each sort of instrument team sort of has their own base, but the people who work within that base can be from all over the place as well. So. Yeah. That's pretty much how it is, and then we just communicate within that base, and one person goes up to talk per operations day. But the first 3 months we all spent at JPL in the same place, and I think that was really important for learning to understand each other's voices, each other's names, each other's personalities, and help bridge that gap between to build that trust and communication within one another.
Yeah, that's where the role of the training can come in. So familiarizing with tools and training, that can be an early step. It can be before launch as well, and continue somewhat after launch. A difference with MSL that it's important to point out is that the lunar stuff is real time. It could be 24/7. And with human crews, it's probably not going to be, but there could be activities going on 24/7 and real communication with feedback.
Great. This is good feedback on physical space. Anyone else have any insights or thoughts on what kind of rooms, or if there's any rooms at all? Or I think this is really important stuff about distributed science support. It's like we have something in the chat.
Yeah, we do have a chat question here. So okay. This is from James. The topic of more direct communications with the crew has come up multiple times in these conversations that we've been having. So when we're talking about an EV crew, we want to keep in mind that there's almost definitely a limitation of a single audio channel with both EV crews. So if the ground is talking to one crew member, the other is going to will definitely hear. This is partially an infrastructure limitation, partially a safety requirement so that something isn't said and then someone else doesn't hear about it. But the safety requirement is that we don't want crew to lose communication with each other as a result of the ground attempting to speak to only one of them. Because of the single communication channel, adding more voices to the channel may not necessarily decrease the communications capability. So that I think that's more of a comment than a question, but I still think that's really important when we're thinking of infrastructure and how we're processing this data. Because again, one communication channel for multiple people is a little bit different than multiple people talking simultaneously on the same communications channel. So those are two important questions that we need to address here. And one of them was brought up before, talking about the Apollo surface journals doing a AI interpretation, logging, the capabilities of that versus using humans. And I think that if we're going to look forward to archiving, the number of communications channels then becomes important. Since you can get a better resolution of who's talking, when, where, and have potentially less crosstalk.
Yeah, those are great comments. So it sounds like the conversation kind of wants to shift to the computing communication topic, which is fine. We've got a couple hands up too. Let's see who's first. Matthew Miller. And then I see someone else after. Yeah.
That's Pam.
Pam, okay.
So I think in terms of the previous topic of the physical space requirement, it's probably just worth trying to note there that the infrastructure and the physical space is going to be a product of the actual work functions needed to be fulfilled in that space. And so rather than think of it necessarily from a physical building perspective, think of it more of a, what are the work needs, and who are going to fulfill those work needs. And if it's got to be distributed amongst many people that have to be co-located versus one person that can sit by themselves in their house, like, yeah, just kind of flipping the question a little bit towards the work functions as opposed to the physical space.
Yeah, that's a great way to think about it. And I think those are the sort of things that could also change as sort of the program progresses. So early on, those physical space requirements will be different than later on, perhaps. Let's see, I see Pam and then Heather afterwards.
Yeah, I wanted to mention something that I brought up in the question the chat area in our session, which is about transcription. So I love the idea of real-time transcription, but I can tell you this, I am a person who is an expert transcriber. And I can tell you that though we've tried for voice recognition software development for decades now, it's still relatively primitive. So the best way to get a transcription is to have an experienced transcriber who knows the voices of the speakers doing this. It's the most fast and efficient by far, by the way, because you don't want to work with a written transcription from a voice recognition software package because you'll never be able to transcribe it. I've tried it. So in terms of getting some real-time feedback, this may be more appropriate in tools, but I wanted to be captured somewhere. So that it's still having an expert transcriber. They're very good, by the way. I mean, they have excellent ears. And if they know the people whose voices are speaking, it's the best way to get a multi-voice transcription of anything that's being said.
Okay. Yeah, I've captured that comment here in the communication slide. Anyone else? Let's see, Heather.
Yeah, I just wanted to comment. I forgot who the name of the person was just before that was talking about the tasks, but generally I would say I wanted to kind of follow on to that comment, which is that I think that the space may change depending on where you are in the mission, or, you know, as far as whether also like if you're in the planning phase versus the active phase. And so there may be multiple spaces that are needed, and that task analysis is going to, I would think, drive that more so. And it may be different teams need physical space and other teams can use virtual space more efficiently. But one thing our team had looked at, I've been working with people remotely for a while, is also having kind of a virtual space that people can pop in and out of as needed, where there may be certain times that different team members are staffing that, so that you can have access to ask questions in an impromptu way. That's something that can be helpful, you know, as people are trying to determine, you know, have different kinds of questions for different groups that may be not co-located and not available all the time without having to plan a meeting. Sort of like office hours in an academic setting.
Yes, that's something I can definitely relate to right now. It's much harder to engage organically with people like students when you're not physically there. And I can imagine the same would be during a mission, right? You know, the science team might want to talk to someone in ops, right?
Yeah, so like, you know, one of the things when I was working at a different company, you know, I would often know things that my team would be like, how do you know that? And it's because I would get up and go and talk to people at the, you know, water cooler or in the whatever, because I wasn't always at my desk. And so they were always really surprised. But it's because I went and physically went over and talked to people instead of trying to do everything by phone or by email. And so I think having a virtual sort of water cooler where people can pop in and out of to have that kind of interaction as needed might be useful for, you know, somebody said the rule for, you know, creativity, to help with engaging for creativity and having those sorts of kinds of discussions that wouldn't happen if you have to plan a meeting.
Great, thanks. Yeah, I think I've captured that here. Let's see, KV Logan, you have your hand up.
Can you hear me?
Yes, I can now.
Okay, thank you. Along the lines of computer needs and database organization and information and then so-called drinking from a fire hose, having so much information that it's almost impossible to find what you might be looking for. I mean, and this workshop is an example because there is so much information being shared that, it's almost impossible to assimilate everything that we are hearing. So what I would suggest is to organize things using a systems approach. And a number of people talked about systems in their presentations. But what I'm talking about is using the systems approach kind of as a table of contents. As an example, the NASA space exploration program can be seen as a system in itself. And then subsystems would be the moon, Mars, the sun, anything else that is involved in NASA space exploration. Those would be subsystems. So in the case of the lunar subsystem, then you would have the Apollo EVAs and the information that comes off. And so each of those would be a further subsystem of the subsystem. And each subsystem could be hypertext. So initially, you would only see the main title, NASA Space Exploration Program. So then you would tap on that as a hyperlink, and then you would see the subsystems. And then each of the subsystems would also be a hyperlink. And it would be fairly straightforward for all the systems activities that are presently being conducted just to cut and paste, so to speak, into the hypertext areas of these subsystems. So a person would not have to know authors' names, and as in the case of the library, where you would have to use keywords to look things up, you can identify it from each of the systems that are involved in NASA's space program.
Great, thank you. Let's see. I see Laura Donna Bessone.
Yes. Yes. I mean, you were talking about the space. I think the important thing when you're communicating with each other is to have the same mental model. So I think more than the physical space, what is important is that you have access to the same information, and you can refer to exactly the same visuals of what you're actually working on with very exact coordinates. Time was mentioned, but time is not the only one. I mean, you want to know exactly where the rock is, how it looks like, same coloring. And if you're looking at it, you need to look through the same eyes and be able to put the same filters. Otherwise, you have different mental models. So I think more than the physical space, it's important that you have tools that allow you to create that mental model and make sure that you can recreate from the different positions exactly what you want to talk about, such that you are not having misunderstandings. That is one aspect. The other aspect is the operational glossary that you're using, because again, there will be a very wide community coming from very different backgrounds, and the fact that all of them will have one operational glossary that is adapted to moon exploration, because it's not the same as ISS. ISS has a lot of acronyms that everybody knows. Everybody will need to be able to have a same glossary and make sure that when you're using that one, you're creating again the same mental model. I'm done.
Yeah, great. Thank you. Yeah, I captured both those important points. So I'm hearing sort of a common message here that perhaps new tools for sharing data for virtual collaboration might be more important in some respects than physical space. And then I like that idea of a operational glossary that goes in line with the comment before that. I think about generating a table of contents. So some way of managing data and also managing sort of how we talk about things. Let's see, who else? I think we have got another hand up. Brad Blair, I see you next, and then afterwards Fred, and then I think there's a couple of comments in the chat that I do want to recognize. So go ahead, Brad, I think you're next.
Jose, can you hear me?
I can hear you loud and clear.
Good. I think these classification systems are of immense help, but one of the things, looking back on your sort of master list of what we're talking about today, that seems to be missing. I see comms. I see. I'm going back to it. Physical space. I would also say, kind of like see the computing resources as kind of like a digital space, because you can do online collaboration. There's so much of that during a pandemic happening, but sort of managing the physical and virtual space to integrate communication messages. I think what's really missing from this set of questions is decision criteria, or criteria for ranking the importance of a mission. And the example I would use is if you've got some type of a human operation that is getting into a potential safety issue. Somebody could be walking down a steep slope into an open crater, seeing a very interesting geologic feature that could be very high priority, but the safety people, I think, would have to be put into a kind of context where they can interrupt the science prioritization to say, hey, we have to throw a red flag. Your slope angle is too high. So decision models, in objective ranking criteria so that you can prioritize, I think is really an important element of all of this, so that once you come up with these different lists and the classification of the data and glossaries, so that everybody can understand and be on the same page, that you can then have a tool for to get past the bandwidth limitations and actually make sort of real-time decisions in terms of priorities. So.
Yeah, thank you. I think that's really important, and that is a good catch of something that's missing. It's interesting. It's another example of where sort of digital tools and sort of those decision-making sort of frameworks are kind of almost trumping sort of physical, tangible kind of assets. But yeah, I've made a note of that here in the tools and instrumentations part, and hopefully that will make sense. Let's see. Fred had his hand up, and then Ben. And then don't let me forget, Marie, to look at those comments in the chat.
Yeah, hi. I think I'll follow on this theme a little bit. We do have to manage large volumes of data, and there's no doubt, like, you need table of contents. You need a lot of metadata. When and where and at what angle and from who took this picture and what instrument. Where was the astronaut this time? Where did this data set come from? Does it overlay our base map or not? All those things are important. I'm just thinking about the Mars missions that we have, volumes of data every day from various instruments, and having a science team and even an engineering team be able to sort through that in ways that make sense to them. We use like a lot of different ways of referring to data. Sometimes it's by sol, the day that an operation had, but it can also be referred to by the rover location. We often have parlance of a RMC, rover motion counter, which counts basically like where the rover was at a certain time and state. But that, those don't always match, right? So you can be like, you can be at a place for like 20 sols, 30 sols at one location. So there's that. And then there's locations that overlap each other. Like, if I'm looking at this rock, how many pictures of that rock do I have? And how far away are those pictures? So all those become important. But I think, and someone talked about time. And I think Pam Clark started to talk about, location means a lot, right? I mean, you may take a picture of a rock from 2 different days, but but it may be the same rock, right, spatially. So having multiple ways to search through your data is important. In terms of tools, you know, I think we have to think about different modalities and as well as different capabilities. You know, VR is awesome. I've used it. I've used like the HoloLens stuff that, you know, were used on MSL. But you know, not everyone has a VR headset. You know, just looking at a generic image might be the way that some team members can communicate. So like, you know, like just an example, like Perseverance. We have an image browser, the Mars Viewer, Planetary Image Viewer. We have Astro, which is kind of like a 3D targeting tool, which is like somewhere close to VR, except you don't put it on your head; it's still on your, you know, your screen. We have CAMP, which is Campaign Analysis, Mapping, and Planning, which does strategic mapping planning. And then we have, you know, Cacher, which is a reporting tool. So like we have a host of software that are all kind of interlinked together. And the other important thing that we also capture now for this mission, first time, we actually have round trip tracking. We track commands that go up, data that's collected and data comes down, and tagged to that is science intent. What was the goal for taking this image? What was the task that had a science request for taking this image? And I think that's going to be very important too. So again, it's like when we recreate these data streams post surface or maybe even during surface, you know, why did you walk over to that boulder? What was it? What was the reason for that? And so kind of, again, like thinking of data not as data, but as databases, having data that's stored in such a way that you can search through it through the terms that you want, you know, time, location, science intent, science goal, you know, and then relate to that, you know, maybe a certain mineral you're looking for or feature or form. Anyways, I'll stop there, but I think it's managing the data is so incredibly important and often gets overlooked. We collect a lot of data, but we don't always manage it well.
Yeah, thanks. I think that's going to be really important, especially with the large amount of inherently digital data we're going to be getting back. We need to be able to deal with it in real time. Let's see. I see Ben and then Brian Day afterwards. Just a note on a time hack. We're about halfway through, and we've got a lot of good stuff here. I do hope we get to some of these other topics also. So Ben, go ahead.
Yeah, just to pick up on what Fred was just saying, and maybe to shift gears a little bit. In the tools and instrumentation, this implies something we all know that will happen on Artemis, or is very likely to happen, in that many, many different teams will be building tools completely independently in silos from one another. And so I think what I would like to see as a finding that comes out of this is that we need a top-down approach to data organization, which is exactly the point Fred just made. But it's more than just like on the mission and we're all trying and we're all working together to do that. But there are going to be groups that have never met each other that are generating data that, you know, are coming back and they're expecting it to come over the pipe. And we can't have, you know, if there's 30 instruments on the surface, we can't have 30 different science backrooms on the ground that are not compatible with one another. So we want to make sure that there is a very strong hand being applied to anybody that's delivering this data, so that all of that metadata that Fred just mentioned is all consistent. And of course, you know, I harp all the time about timestamps. All of that stuff, everything comes down in a compatible package, and that suddenly unlocks it. And it's not hard to make those kinds of requirements come true. You almost get that for free as long as it's done early enough in the design of the instrument. And then suddenly all that data is unlocked in a new way for different types of visualization and usefulness on the back end. Anyway, I'll stop there.
Great, thanks. Yeah, I think I've captured that. Brian Day, I see you next.
Sorry.
Yes.
Could I just really quickly, just before I lose my thought on that, what he just said is that it seems to me that maybe this already exists and I'm just not aware of it, but that there is a possibility of having an ICD for this kind of data handling that would be a standard for, you know, all groups that, you know, like in the HRP, they have sort of like the standard measurements that they're taking, health measurements, and sort of across all experiments. So if there was something similar of a list of metadata that needs to be captured for everything, and maybe there's some that are not going to be relevant for certain types of, you know, data, but that could be something that's prescribed across groups so that you could match it up. And then one thing about the timestamp, I heard, forgot who was talking about the timestamps earlier, but I was wondering, they said 1 second, and that seems to me with work that I've done, 1 second isn't really accurate enough to sync things up. And so really knowing what that accuracy, do we need milliseconds or, depending, maybe it really just depends on what you're trying to do with it. But I think there should be some discovery about what the minimum time besides 1 second, like less than 1 second, would be required for certain types of data to sync them properly.
Yeah, Jose, I'll just take that because Cameron's not here right now, but he was the one talking about that. The reason we say 1 second is that what we're trying to say there is that it'll work even if it's as low as 1 second. We're not talking about some kind of new level, and this comes from the fact that we're using ISS data right now where there isn't much time synchronization going on. And really we're just trying to create a situation where you pull up data in an interface and that photo that was taken is next to the telemetry stream that the two have never met before. And if that's within a second, you still get this kind of context back and it's a useful view. I completely agree that if we can make it, super granular and much more data synchronized than that, especially if you're using data synchronization for any of your analysis, you'd want to make that, at millisecond level. But that's where the 1 second came from.
Great, thanks for that. Brian Day?
Yeah, just wanted to jump ahead a little bit here to the specification of what software tools we're going to be needing. And one of the things that became really clear in our discussions today is the diversity of applications and the user base that we're going to be encountering here. This is going to be far more complicated than Apollo was. Now, understandably, management oftentimes is very almost seduced by the idea of the simplicity and economy of a one-tool-fits-all solution. But something I really appreciated hearing today was the idea of not necessarily looking at a monolithic solution, but looking at a coordinated ecosystem of products. And that is probably going to be something that we might want to emphasize the need for. And currently there's been the independent review board for the planetary data ecosystems, and there could be some valuable lessons learned for us from that effort.
Great, thank you. Yeah, I think that's really important. Let's see, anyone else have a hand up? If not, let's look at some of the chat comments because I think there's some important things to capture there. So let's see, to start, the topic of more direct comm, this is from James Montalvo. More direct comm with the crews come up several times. When we're talking about EV crew, keep in mind that there is almost definitely a limitation, a single audio comm channel with both EV crew. I think we've talked about this one already. Let's see. It's another one from Brad Blair. Has anyone done a survey or made a list of flight operations clusters or capabilities across NASA enterprises? Coming up with a list of relevant examples could streamline finding best practice examples. Another one from James Montalvo, machine transcription for ISS. I think we've talked about that. See, Marie, you had a note here on physical space. Do you want to talk to that?
Sure. I think we are all very much in the COVID mindset of right now we are thinking so much about virtual, but physical space I think is actually going to be really important. As on MSL, as we have tried to transfer away from in-person operations, there have been some groups of people on the team who have had to try and stay within the loops, within multiple communication loops. And that is possible, but it's actually very difficult when you're in a mindset of trying a certain timeline to get a tactical operation done. So there are people who've had to buy 2 headsets, break them, put them together, and then they manipulate the volume and the microphones on each one so they can listen and participate in 2 parallel meetings at one time. And so I think it's important to come back to the physical space part to talk about, are we going to have instrument teams have their own rooms? And that's something that we did in the early times of MSL. and each team had their own room, but yet we came to a joint room, like the representatives came to the shared physical space later on. And so if there is something like that happening, I think you're going to need like an instrumentation or a geology group or some different physical space locations that can come back together, because you can only keep track of so many virtual communication streams.
Yeah, thanks. I think that's something we all feel over the last year. I know I've had to be in 2 meetings at once virtually. Let's see. Matthew Miller has a comment. Something also that also needs to be considered is robotic planetary missions. All currently feed into the PDS. How does the latest PDS standard play nice or not with human spaceflight missions? Okay, so I think that is something that falls under sort of this tools and instrumentation as far as data streams. So how do we make it PDS compatible? And let's see, we've got another one for location. The resolution depends on what you're talking about. Okay, so if anyone has any thoughts on, for metadata, to what resolution we need to tag sort of the location of data. And then finally, concur with whoever was recommending we have ICDs. What does ICD stand for?
Interface control document.
Okay.
It basically, and it could be also an IDD, which is an interface definitions document, might be more appropriate, but basically defines what all of the data streams or metadata that you want to collect across instruments or groups or whatever. And it may be, also like it could include what format does it need to be in so that it easily integrates into your, your universal software package that that maybe is going to be created at some point, so that it's, it sort of seamlessly will interface into all the other data streams.
Great, thanks for clarifying that. Okay, I think I've looked at and we've talked about all the comments in the chat. If someone's posted some in the chat and I didn't do it justice, please feel free to speak up. Let's see, we are at 2:15 my time, so 15 minutes after the hour. I think we have another, about 25 minutes or so, if I'm doing my math right. I see a couple hands up. So Brad Blair and then Heather.
Jose, I wanted to kind of follow up on my leading question about surveying sort of control rooms across NASA.
Yes.
And I also really am a representative of Brian Day's comment about other sort of, areas of interest besides science. I'm one of the ISRU/commercial guys that, has been strategically positioning for a return to the moon for 3 decades now, but we'll see if it happens. I hope it does. But I will say that the growing interest in commercial and ISRU is likely to throw some interesting vectors into this, and that's part of why I wanted to add that thing about decision criteria and specifically prioritization. I think that's a really important thing, because the prioritization is how you figure out which one gets first in the queue. And that's definitely going to happen. And I'm sure there's a lot of experience in NASA across that. But I wanted to mention that I'm working with a guy who has decades of experience in underground mining robotics, Greg Baden, and he ran a test mine for Inco with a $500 million Canadian budget that it didn't really get published, but he was running several pieces of underground mining equipment with up to 2 seconds of teleop delay from surface control stations for literally 5 years, and full-time, crew, 24/7 rotations, 3 different crews a day, operating 5 workstations and doing drilling and mucking and haul trucks and the whole thing. But his operational experience in blending that thing between operations data needs and scientific or in the information data needs that you have to get to run an exploration in underground mine project, I think it offers perhaps some relevant lessons and maybe some lessons learned experience that could be valuable to NASA in planning, the hybrid between, human and robotic operations. And an example of that is you've got a machine that's down and you've got an underground crew maintaining or repairing that machine. You have to prioritize their communications and safety over the automatic data requirements of that or use of that machine itself. So it's there's these hybrid situations that there's a lot of industrial experience in. I guess what I'll say, just to sort of summarize this, I don't want to go on too long about it, but I think that what perhaps is called for in recommendations is to have a Artemis data workshop or a lunar surface data workshop, just to bring in the comms folks to talk about prioritization and bandwidth, because I'll guarantee the folks in Goddard that design communication systems for the moon want to understand the requirements that Artemis is going to impose on the communications investments that NASA makes in the next 10 years and integrate that into their planning. So I think this is less of a point solution and more of a dynamic feedback loop that is likely to encounter this prioritization issue over and over and over again. But I would think that kind of a workshop would be a great place for Greg to come in and spend a half hour talking about his experience, so that people within NASA who are interested in understanding how industry solves some of these problems can create that relationship and get access to that information.
Great, thanks. Yeah, I'll definitely pass on that suggestion for another workshop to the organizing committee. Let's see, I see Heather and then Matthew Miller.
So I just, the person who just spoke about prior to this last person about physical space, I totally agree. I guess when I made my first comment, it didn't come out quite the way I was trying to say, is that I think that if you need physical space for teams, but if there are international groups that are participating and you can't be co-located, then how do you create a collaborative space for them to participate with the people who can co-locate? So that's a question. And then I guess as far as designing actual physical spaces, doing the task analysis of what you need to do in those spaces and how you set them up should be done by human factors. I mean, there's all kinds of, ergonomics designers that would be best suited for determining how you're going to actually structure that space, but you have to know what you're doing with that space first, and that may depend on the mission phase. So it may be that having a space that is either reconfigurable to some level, or multiple spaces that are different for mission phase depending on the task. And then how do you integrate the people who are maybe at a distance into that physical space in some way that they can have that be there virtually and participate? Because one thing that I've noticed that happens is that you end up with this obviously sort of siloing effect of groups that are not co-located if you do have the physical space, and everybody, only the people in the physical space work together well, and then you don't have people who aren't there able to adequately contribute.
Yeah, thank you. Yeah, those are great comments that, yeah, I'm really glad you gave those. Matthew Miller.
Yeah, for the tools slides, to me, it also dovetails with my comment about the physical spaces. Like, the work that needs to get done drives what the tools need to be able to do. And it's all about supporting these people do their job. And so when it comes to these tools and instruments, it all goes back to like, what exactly are we expecting these people to actually do? And are we going to make it hard for them, or are we going to make it easier? And so, yeah, just kind of taking that work focused perspective to let it kind of drive what some of these tool capabilities can be, that will end up being necessary.
Yes, that's a great input, and I guess that's another argument for getting scientists involved early on in sort of the definition of mission goals, objectives, and things like engineering decisions. I see.
I guess just and we have started to try and implement that in practice with the EMSS effort that I presented today. Is we're working in tandem with the actual XEVA flight controllers in those simulated tests, where we're trying to simultaneously identify the work that needs to get done, and then in parallel realizing technologies that could support that need. And so the work is slowly beginning, and we're right at the beginning of that effort. So I'm excited to promote that workflow with this community and the broader community moving forward.
Yeah, thanks for that. It is really exciting. Jonathan Ralston, I see you have your hand up.
Hi, everybody. Probably just a +1 to the comment that Brad made. I'm from Australia, so it's great to be joining you all. The Australian mining industry and all the lessons learned, absolutely a fantastic opportunity. We're looking at in situ resource utilisation as well, pretty much as a driver in support of provision of lunar foundational services. And so we're looking very closely upon all the lessons that are mentioned in already touched upon, such as remote operations, resource sensing, maintenance, all the sustained operations aspects. And then from there, really identifying what the exciting and challenging science and engineering problems need to be solved. So getting an idea of the priorities for development, very, very important in terms of, boots on the moon to sustained presence. So I would just like to echo my support if there's an opportunity to share some of the insights from the resource industry. And I guess some of the momentum and some of the opportunities to spin in some of the technologies and even spin out, that would be a really valuable opportunity, I think.
Great, thank you for that. And again, I think that might be another possibility for another workshop at some point. Marie, you have your hand up.
Yeah, I think another part of the tools, as we have seen during this meeting, a chat type feature, some sort of chat communication between with multiple channels is a really useful tool. So you could have chats within your own specific group of people who specialize in something, as well as a chat with operations people or with like mission people as well.
You thinking like text chat exclusively, or
like
video?
Like a Slack channel type thing?
Yeah. Slack is great. It can be overwhelming though too. So yeah, just like audio channels can be. Let's see, anyone else with a hand up that I might be missing? All right. Okay, we're down to like the last, 7 minutes or so, and we've got lots of great stuff. I do want to circle back and make sure that we've captured any and all comments, to whatever degree of specificity we can get on any of these questions. So physical space. We've talked a bit about instrumentation. We don't have a whole lot of specificity as far as specific data streams, their relative priorities, and things like requirements, and then dovetailing with the requirements. What kind of things do we want to say about computing and comm? And I do want to bring up one thing just to maybe spur some conversation. There was a lot of discussion yesterday and throughout today about the degree to which and how we communicate with the crew. So what kind of sort of infrastructure issues are related to how we communicate with the crew, as well as amongst the science team. So open floor for the remaining, I think, 7 minutes now. Heather.
So I brought up a comment yesterday about using the cave as a way to collaborate, having scientists that are Earth scientists being able to collaborate in real time or near real time with the crew. And I just wanted to bring that back here as when we're talking about the data streams is that if you're going to use anything like virtual reality or, you know, that kind of cave system or whatever, is that would feed into the kind of data you need to be collecting in order to make those tools feasible. And, you know, also like say on different instruments, you know, whether or not you're going to take point clouds to be able to integrate, you know, all of that information from those different tools into a 3D space. So I think it's determining what kind of virtual reality tools or augmented reality tools you're going to use is also going to have to go into what kind of data you need to collect. So I think there's got to be some architecture decisions first before you can really do an ICD or an IDD for the different metadata that you want to collect from all the different streams.
Yeah, great. Yeah, I think that's really important. You know, I think VR was something that was mentioned a lot today, and you're right. I think defining the kinds of data you need to inform that kind of a system is going to be a big driver there. Anyone else? Does anyone have any thoughts on sort of this notion of how we communicate with the crew, or some more specific thoughts on data streams and how they might be prioritized? I've seen you hand up, Brad, Blair, and then Heather again.
One thing that I looked into when we were doing the data reduction process with the lunar drilling stuff, Deep Joshi's paper earlier today, is you know, sort of the current state of the art of AI, ML, you know, computing capabilities to build an artificial intelligence model to do that front-end data reduction, and do it on the edge, sort of edge computing, as well as you know, with the sort of rad-hardened space-qualified hardware. And those capabilities, I think, are really important to understand when you're doing, you know, Jose, you had that simulation of some of the sort of data streams and management in robotic and human exploration. I think a simulation model is great, but you also have to understand what the kind of like realistic constraints are in the computing capabilities that'll be rad hardened and flight qualified to do that sort of front end data reduction, so that you don't oversample or you know, bog that resource down, or you can dynamically reallocate it. Once you've done a data reduction, you can then use that model to extract features without having to send so much information home. But there's a lot of, I think, interesting nuances in there that can definitely be tested in field campaigns. But I'm sure some of the older versions of you know, NVIDIA's machine learning platforms, you know, may be similar to the current state of the art of what edge computing can do, and AI/ML systems that are space qualified. So we've got a few years to advance that. Maybe there's a partnership with NVIDIA to flight qualify some of their better hardware too.
That'd be cool. That would be really cool. Heather.
So I guess I had a question. It's sort of a question before I give you an answer. You said about communicating with the crew, and my question is that, at least from what my understanding from certain projects, is that sometimes the crew, I mean, I think we've been thinking more about us communicating information to the crew versus the crew having questions back to us. Or are you asking about both?
I would say both. You know, I for one, I think it's equally important to get information back from them rather than the science team continually just giving them instruction.
Right. So I think, just following on to my office hours question, I mean, typically you would have, if you're, you know, I would imagine that whenever the crew is working on a particular experiment, that there's the scientists are basically in the back room or whatever we're calling it, or on console, so they can answer questions. But if you have these jars of get ahead tasks or extra science, you know, then you would have to have people staffed at all times if you weren't expecting them to be working those tasks. And so that may go back to, you know, also having sort of office, so to speak, office hours, or only having the jar of tasks that you're going to have staff there. Because if you don't do that, they can't, like if they try to take a task on that wasn't planned because they have extra time and you don't have the staff there, so there's still got to be some coordination, or there has to be certain people always available in this sort of office hour situation where the crew can access them as much as other scientists can access other scientists.
Yeah, I think that's a really good idea. Have flexibility with how we communicate with the crew. I think that's a really important thing. Let's see, we are pretty much out of time. I see one more person with a hand up, Colin Roscoe. I do want to hear from you. Take it away.
Hi. My concern is with we're sending the communication data through. So from the MCC perspective, we get the data in, and then we're behind a firewall, and we need to be able to get that data out. And with on-site, it's not such a big deal because we can just have that data accessible through a single route to the SSR. But if we're trying to do co-location or something like that, is there a single repository that the data would want to go to, or is it several individual locations, like out to like ESA or something like that? Where would a good option be for the data after MCC receives it?
So let me see if I capture that question right. And we do need to head back to the plenary. I just got word that they're waiting on us. So you're asking sort of what happens to data that's collected? How is it stored, archived? Is that right?
Yeah. How can it be made available to the science teams?
Yes, absolutely. Yeah, that's definitely something on NASA's list. You know, how do we handle large volumes of data and make it available? So I think something like the PDS, you know, that's always going to be important. You know, so how do we make sure that human spaceflight mission data is compatible with that? Okay, I do see Heather, you had your hand up. I'm sorry I won't be able to call on you because
I forgot to lower it.
Okay, all right, great. All right, we do need to head back to the plenary now. Thank you. Thanks to everybody for your great input, and I'll talk to you in a few seconds. They're all waiting on us. All right, so we'll head back to the WebEx we used for the rest of our talk. Thank you.